Significance of 555. So 3 5 kilo ohm resistor connected in series to each other, and in between we will consider the voltages. So 3 5 kilo ohm resistors connected in series. So here we are taking one threshold voltage, and here we are taking another threshold voltage. So this is the internal diagram of 555 timer IC. And now we are going to see that how this is going to operate in Schmitt trigger. So Schmitt trigger, we already know that Schmitt trigger is a circuit which will convert sinusoidal signal into square waveform. Schmitt trigger is a circuit which will convert sinusoidal signal into square waveform, and the circuit we have seen it with respect to op-amp. The only difference here is the number of components used for external components which we connected with the IC will be less if we use 555 timer, and if we use op-amp, you can check the diagram. You will have a feedback resistor, input resistor. There will be a voltage divider circuit R1, R2, which will provide a feedback to the positive terminal. So the number of resistors present will be more. If we use timer circuit to operate as a Schmitt trigger, in external we will have only two resistors. Two voltage divider resistors we will have R1, R2. And if we consider the middle voltage across R2, it will be approximately equal to VCC by 2 if both resistors are same. If R1 and R2 are equal, you can apply. How we can find this voltage? This voltage, the total voltage is VCC into same branch resistor divided by total resistor. So if all the resistors are same, I'll write it here. If all the resistors are same, VCC into R divided by 2R, R will get cancelled. So this voltage will be, yes. Hope you can hear me. So these two resistors, if it is same, this point voltage will be VCC by 2. Apply voltage divider rule. So here we are assuming that, sorry, I'll write it here. VCC, the resistors are same. So VCC divided by 2R, which is equal to VCC by 2. That's the voltage at this node. This node means the voltage at this node to ground. So here we are giving input voltage. Where we are giving the input voltages, when we compare it with the 555 timer, the input voltage we are giving it in the 6th pin. So this is 6th pin, and another pin we are going to connect is the 2nd pin. 6th pin and the 2nd pin. 2nd pin is operating as a trigger which is connected to the lower comparator, and the 6th pin is acting as a threshold which is connected to the upper comparator. We know that when the upper comparator voltage, when the positive, this terminal voltage becomes greater than 2 by 3 VCC, this comparator will be on and it will reset the flip-flop. This will reset the flip-flop. And if the input voltage, here 2nd pin, how the lower comparator works, when the input voltage at 2 becomes less than 1 by 3 VCC, output will become VSAT, and this will set the flip-flop. This will set the flip-flop. So when set is working, Q bar will be, when set is there, Q bar will be equal to 0. Output will be equal to 1. When reset is there, Q bar will be equal to 1 and output will be equal to 0. So we are having a resistor which is connected from VCC to sixth pin, and sixth and second pin are connected together, and from second pin we are having another resistor connected to ground. So externally, compared to op-amp we will have feedback resistor, voltage divider resistor, input signal we will fed it through a resistor. So here the external components connecting with the IC is very less. In 555 timer, external components we connect as very less. So how this will act as a Schmitt trigger? So consider there is a, I'll draw it here, then we will see the waveform later. Sinusoidal signal. So there are two thresholds. One is 2 by 3 VCC. I'm approximately taking this. This is 2 by 3 VCC. And this threshold, assume it as 1 by 3 VCC. So input is a sinusoidal signal. One threshold is 2 by 3 VCC. Another threshold is 1 by 3 VCC. So we will check which comparator will work based on the input voltage. The same input voltage we are providing it in sixth pin as well as we are providing it in second pin. The same input voltage we are giving it in sixth pin as well as we are giving it in second pin. And both the pins, sixth pin is connected to upper comparator, second pin is connected to lower comparator. So comparator, these are the signals we are providing. So when we consider when the sinusoidal signal is increasing, here if you see sinusoidal signal is starting from 0. I'll take another color. So sinusoidal signal is starting from 0. So 0, it's increasing. When the input signal is 0, the input is 0. So 0 is given here. 0 is given here. 0 is coming to trigger pin. So 0 here, what will be the output? Lower comparator output will be 0 is given to both the upper comparator and lower comparator. Lower comparator output will be, can someone tell? Lower comparator output will be plus Vsat and upper comparator output will be minus Vsat. Upper comparator output will be minus Vsat and lower comparator output will be plus Vsat. So this flip-flop is set. When the input is 0, 0 is given to both the comparators, the voltage will be compared and the flip-flop will be set. When the flip-flop is set, Q1 will be 1, Q bar will be 0. So we will get an output. So here, when I draw the output waveform, output green color, I am drawing it as output. So we will get a high voltage. So when this is coming, when the input voltage crosses 2 by 3 VCC, till this the output is positive, and I'll draw it bottom also. It is positive. Output is 1. That is a high voltage is coming as output. So when the input crosses 2 by 3 VCC, I'll take another color. When the input crosses 2 by 3 VCC, so this is 2 by 3 VCC. When the input crosses 2 by 3 VCC, assume that the input voltage is greater than 2 by 3 VCC. When it becomes greater than 2 by 3 VCC, here greater than 2 by 3 VCC. So when it becomes greater than 2 by 3 VCC, this will become minus Vsat and here it will become plus Vsat. The output will become plus Vsat. Positive greater than 2 by 3 VCC. So it will become plus Vsat. So the reset pin will be enabled. When the reset pin is enabled, Q bar will be 1. Output will be 0. Output will be some negative voltage. So the input voltage is increasing, that is present. Then it is decreasing. When it decreases less than 1 by 3 VCC, next threshold, When it becomes less than 1 by 3 VCC, lower comparator will be triggered. When the output becomes less than 1 by 3 VCC, here it is less than 1 by 3 VCC. So consider here it is 1 by 3 VCC. 1 by 3 VCC means upper comparator will become minus VSAT, lower comparator will become plus VSAT. So when the lower comparator becomes plus VSAT, the output will be in this point. When we draw it, it will come to positive. Then again the input voltage increases, and when it crosses 2 by 3 VCC, output will decrease. Like this, a sinusoidal signal is converted into a square waveform.